All right. Okay. So high performance and parallel programming. Chapter 1, Introduction. Outline of this chapter 1. Yeah. So basically, this is the first meeting and this is like introduction. So we need to know the requirement. Why do we need HPPC? Similar to our assignment also, we need to impress the people. Why do we learn this kind of technology more on the parallel, using parallel computing and so on. And second one, application of HPC and parallelism opportunities and also challenges in this HPC. Yeah. All right. Important of HPC. First, to solving a complex problem. Okay. So first, enable simulation, modeling, and analysis of large scale complex system. For example, climate modeling, drug discovery, astrophysics, big data, ocean data, so many things. Yeah. All right. And second thing, tackle a problem that are computational infeasible. Yeah. Feasible with traditional system. All right. And second, accelerating scientific discovery for speeding up research and innovation in fields like genomics, material science, and AI, yeah, artificial intelligence. Second, reduce time to solution for critical scientific challenges. Okay, so this is quite interesting. Most related, this chapter 1 most related to your assignment that I just mentioned just now. Okay, you can choose any topic and then you explore that. Okay. And then driving technological advance. First, power breakthrough in AI, machine learning, and big data analytics. There's a current technology they use. Yeah. And support the development of cutting edge technology. For example, autonomous vehicles using what you call this ad hoc networks. Yeah. Quantum computing, recent technology also. Okay. So this is the advanced driving technological, yeah, that we're going to use this HPC. And for economic and competitive advance, first enhances productivity and efficiency and industry, for example, finance, energy, and also manufacturing. Second, provide a competitive edge by enabling faster decision making and innovation. Yeah. Okay. For application of HPC in scientific research, which is a great challenges. First, modeling of human organs and bones medicines. We need a huge data. We need to compile image processing, everything. So it takes a lot of data and then lots of calculations, complex also. Okay, modeling of human organ and modeling a global weather, modeling of enzyme activity, protein folding, genome sequencing, so all these requirement. Some of the requirement and great challenges if you use the HPPC to improve this. You can find the paper which is related. So that's why I need you in this class to explore this. Yeah, that's very important. And then for artificial intelligence, the current trending right now is the intelligence, and also most of them most related to the machine learning. It's quite famous. We are using machine learnings and also improve that. Okay, it's not just the machine learning and also this kind of artificial intelligence, but in HPPC also we combine all this, how we can improve. So you can see that here, deep learning, neural network, image, speech recognitions, okay, they are using this. And also big data processing. This is the current trend, yeah. So This is the kind of the application. That's the technology they use. Okay. And then benefit of parallel computing, provide cost-effective solution at the end. So many things. Benefit is so many things. You have to explore. Improves a lot of things. Very small, and then how to improve. There are many researchers go for that. Okay, there comes with their solution algorithm whatsoever to improve certain what we call this benefits. I can't say that. Okay, but you have to explore, like improve computing core, improve accuracy, improve accuracy, and so like cost. There is one my student did on accuracy and also improve scientific. I can't remember that. Yeah, one of the accuracy, response time, for example, speeding. Okay, there's a sum of the benefits. So you have to explore that. Okay, how to explore, but based on fact and figure, you have to go through the Google Scholar. Okay, that's the best resources. Whatever you say, yeah, there is a fact and figure. Okay, evidence or cover whatever you mentioned there, yeah, in your paper later on. So increase the utilization of existing resources, provide faster also, see, faster for industry that concerned about how fast the progress is made. So this is one of the benefit or achievement that they're going to achieve by parallel computing or HPPC. Yeah, right. Parallel computing definition: perform multiple computations simultaneously, involve breaking down a computation problem into smaller independent tasks. All right, just for your information, this class we were going to use a Linux. Okay, Linux. I hope everyone learn the Linux because I'm planning, because there is a very short course. I'm not sure whether I have got time to open a Linux. What we call this? There is a Linux 1, 2, and 3. It's quite a lot, but I'm not sure whether, because previously we don't give any Linux very short course, but I ask students to learn this by yourself. All right. So try to do that because there is. I can't do at the moment because we in Cisco also there is a Linux program in the programming language. There is a Linux courses. Actually, there is 3 versions now, 1, 2, 3, and also advanced. Okay, but anyway, there's just some regarding the language that we're going to do for this class. Yeah, so parallel computing. Okay, Linux or you can say the Unix. Yeah, Unix environment. So parallel computing definition: performing multiple computations simultaneously involve breaking down a computation problem into smaller or independent tasks. So now it's a fundamental concept, parallelism. We can say that a computer system equipped with multiple processors that supporting parallel computation. Yeah. So there's a general term, so concept of parallelism. Okay. Parallelism is not a new thing. Okay, of course, it's not new things. We have this kind of the big, I'm not sure, supercomputer. If you remember that, UTM got a supercomputer a long time ago, 20 years, almost 20, 12, 10, 20 years ago. We have a big Cray, we call Cray, located in KL. We bought that but we're not open for the commercial at the time. So now we just have a big, big machine in KL. I'm not sure where is it, but its name is a Cray. Supercom actually at the time. So now we don't have kind of this anymore because we have a new technology they call it cloud. Okay, cloud computing. We that a cloud, so the combination of the processor all over the world to provide services instead of the big one we bought it. So better to use the small computer we combine like cloud. So we provide the facility or service to the user. Okay. So that's it regarding supercomputer, which is close related to this parallel. Yeah? We use that coding parallel on that machine like previously. So parallelism is not a new thing, actually. Familiar concept in the world, for example, in construction houses or building, in manufacturing, in customer service such as call center and also juggling. Yeah. Parallel activity in construction of houses or building. for example, wiring, plumbing, framing, roofing, etc. Some tasks may be performed simultaneously, some not. Yeah, some tasks need to be performed sequentially. For example, they said here framing preceding proof, for example. Yeah, and ordering requirement of tasks restrict the degree of parallelism, increase degree of interaction between workers. So parallel activity in manufacturing. Okay, for example, pipeline parallelism, strict ordering requirement, each worker stage do different task routine, maximum degree of parallelism is equal to number of stages workers in the pipeline. For example, they give here manufacturing of cars. Yeah. And parallel activities in call center, yeah, call independent to other calls. So the server therefore less degree of communication between workers. Maximum degree of parallelism is also equal to number of stage workers in the call center. All server or worker do common routine procedure. So this is one of the example parallelism. It's like we call this in not interrupt. Interrupt also part of that. What else? In the network programming, there is a term word we use at the same time we do another task. What we call that, class? If you know that. Trade. Yeah, multi-trade. Yeah, trade is one of the example of parallel activities. Yeah, multi-trading. At the same time, we do a trade. By default, it's a single trade. Yeah, when we do a code, there's a single trade. If you want to activate the multi-trade, so you have to know how to. So parallel is, I can say, is one of that. Yeah. Okay, so that's regarding multi-trading. Example of in networking, yes, but now we don't have that kind of the classes networking programming anymore, but we convert to the security. Yeah, all right. Existence of multi-core computers. Okay, so performance of improvement of single chip processor has reached the limit. Of course, that's why the Cray. I told you just now, the Cray. Therefore, multi-core architecture were developed. Each core consists of its own instruction, execution engine, and cache memory. If you learn COA, you will know this kind of the scenario. Okay, all right. Supercom here, commonly owned by government or large. This is technology 20 years ago. Okay, maybe because let's say here, not just a one super Cray, not super. It's a one supercomputer we got here. You can see here, huge to support. So that's why they say government or large corporations. But now, of course, they need to reduce the cost, everything. So supercomputer is no more related. I can say that. Okay, but more than goes to cloud. So quite cheap. They all combine all over the world and then provide the services. Okay, this is how we solve this issue, okay, regarding parallelism. Yeah. And then basically supercomputer used to solve a large or complex computational problems. Supercomputer have 1,000 of processor inside. Okay, one supercom, and then this is a combinations of many supercomputers. You can see how fast they can provide the service to the user. And then cluster. So this is another idea before we go for the cloud. This is a cluster. Cluster is one of that combined. Developed based on the idea of combining many commodity machine computers to produce a faster computer that can execute more instruction. Yeah, more instruction per unit time. Okay, you know that we learned that we call this concept of so many concepts, okay, related to this cluster. It's like pipelining, okay, and relatively inexpensive as it is constructed of the commodity computers. Okay, you can see here, small scale, okay, to develop this kind of the. Okay, so we are not going to, you don't have this facility, and then we're not going to, because this is quite a big money to produce all this. but we just do on programming side. Yeah, most of in UTM is more on programming side. So maybe another institution, yes, provide this kind of because we need the hardware, need tools, so costly actually. Yeah, if you go for this kind of the how I call this training and everything, learning of use. That's why if you see in UTM, okay, you don't have this kind of the less exposure on hardware actually, okay, or hardware because this involve a big money, okay, instead of software. That's why, okay, that's why if you go to Cisco program now, they have got the simulation based on physical mode, okay, so try to reduce the cost. Okay, at least student learn, and then maybe in future we have got AI right now. They combine this software to the machine directly in order to manage all those services, everything. Okay, that's a future, future technology related to this. Okay, so that's the issue. Right. Okay, right. So that's regarding Cisco. Okay, internet work servers. Okay, this is the scenario. Okay, this one also is good if you want to explore to this kind of the area. So that's why when week by next week, if you give a title, so I will go through each of the title and then I will give suggestion to improve your content. Yeah, no worry about that. Okay, so here you can see internet work servers, expansion of internet and popularity of remote services cause servers are deployed, okay, and connected over the global. This is such as Facebook, Google, and many more, okay, Amazon, and so on. Okay, this is I can say that combine all together and provide services, okay, so they can generate income and so on, so many things. And then typically computation are independent tasks such as search, query, processing, and then connected servers mainly to implement distributed computing. However, concurrent execution of server machine on solving those independent tasks result parallel computing. Yeah. And this is another before cloud, we have this grid computing or grid computer, similar to internet work server, where computer machine are connected to the difference is that grid computer consists of machine with various type, yeah, and specific. This is, I think, just the combination of, the various type, the structure. Okay, this is a grid computing. Okay, those machines can be owned and managed by organization or could be by various organizations or personnel. Yeah, grid computing. Okay, and then there's some concept speed up. Okay, speed up equal to sequential execution time divided by parallel execution time. So this is the equation: sequential divided by parallel. Okay, for example, the sequential execution is a 10 millisecond, parallel execution is 5. So speed up is 10 over 5 is 2. In the other word, the parallel computation is 2 times faster than the sequential computation. Okay, all right. So these are the concepts. Okay, these are also some theory before we implement execute. There's also another part of the area that you can see to speed up, to improve the speed up, how, all right? It's a quite challenge, this topic, yeah? So this is like an ice break to your assignment 1, actually, yeah? So you can go for the speed up issue, how to improve. So you can find out the paper which is related to the speed up and also scalability. Okay, what is scalability also? So key concept, maybe some researchers want to improve the scalability more on theory. Okay, they can, so many areas actually. So that's why I open this topic for you to find out and explore. Yeah? Scalability refers to the ability of system, network, or process to handle a growing amount of work or to be expanded to accommodate that growth. Okay, scalability. And ability of a parallel system to maintain performance as the number of processes increase. Those also another things. That one also you can, very small, niche issue, but there is a reference. The one it can be some, you know, you can say, gives at least what you're going to present, the issue, the topics, but there must be evidence, okay, evidence from the 5 years. Maybe within 5 years, what's the current, uh, let's say, yeah, let's say ability to balance, to maintain performance. In within 5 years, is it this one still, I mean, still, we call this, the work is going on within 5 years back? So we need to find out. If there is, so why not? You just explore, discuss, and present your works and present your discussion to the audience in the conference later. See, and of course to our class. But our class, you no need to present. The final presentation is in your conference later on. But in the class, only just for the sake of I need to review all the papers. Make sure there's no copy and write everything AI generated, because we are using Turnitin, right? Okay, then we'll check so everything. All right. Is ensure the performance and efficiency. This is another parameter. Performance, one parameter. Efficiency is another parameter. Also, what technique they use going to improve efficiency. There is some discussion also. They use this formula, they combine, they modify everything, they combine, and then they say, okay, this can improve. That's why they publish the work. Someone will read their works, and then someone will verify this fine. Okay, it's not just we create and then we not justify everything. So because everything that you publish your works, everyone will read your works. And something wrong, so they will complain to you. Okay, so that's the academic style. Okay, that's why we publish the work, to let people read our contribution. Okay, and of course every contribution there is some improvement, there is some result, good result, everything that need to share to all of the viewers out there, especially to the researchers, to improve again and again. Okay, to get a better life, for example. Yeah. So is ensure the performance and efficiency, two parameters now, are maintained as demand increase, whether by adding more resources, hardware, software, or optimizing existing one. Okay, this is the one example. Okay, one of the example that I can say, performance in what? I don't know. Maybe HPPC, of course. Right, so you need to explore that. Okay, so within these 2 weeks, okay, you need to explore all those, kind of the opportunity, how you can, manipulate the idea, everything. Okay, so later I will show up the e-learning, yeah, the assignment. So this is the calculations. Okay, efficiency, speed up, divide by number of processor. This is how they can. So you can explore this, no problem, but it's quite complicated because we are not the mathematician. But everything, yes, from the mathematician, the idea, the calculations, how to improve that is based on this, actually. But there is another issue that you can explore instead of this. Okay, so many things. So from this is the detail. Not necessarily you have to go for this to improve this formula to get the best efficiency. But we use efficiency and maybe from the algorithm, so that you can improve the best algorithm to improve this efficiency, for example. Okay, this is the only calculation. Yeah. All right. So this is another things. Okay, efficiency. This is the aspect of the granularity. We have the definitions. Okay, fine grained parallelism is a break task into very small, tightly coupled. For example, this is technique we have heard during operating system class, right? And coarse grained parallelism divide tasks into larger independent units, for example. And then granularity, for example, for aspect granularity, we have a small task. For example, individual instruction or loops, okay? And for the coarse grain, like a large task, so we go for the small task, divide that, yeah? And aspect of communication, frequently communication between tasks, less frequent communication between tasks if we implement this course, and also fine grain. Okay, so we have the many kind of the key concept, yeah, concept of cost, grain to define. Of course, fine grain is a better, and there is some reason. Then some what you call this. This is the keyword overhead, for example. Which one is a better? So I also doesn't know, but everything is from the result from the journals. Okay, so for example, even this topic also get from the journal. Someone research can analyze about this, so we present to you. This is the from the research work. Every that we learn, every subject, every syllabus, everything in computer science or whatsoever discipline, everything come from the research work actually. And then we combine that as a module subject to give to you to explore. Okay. So when you go for the research, go to the PhD level, master, and so on. So we'll develop a new technology. That's why. Yeah. So this is the current education style. So overhead for what? For fine grain will high communication and synchronization overhead. And for the coarse grain, they will say lower overhead due to fewer instruction. Got the coarse grain, right? Okay, scalability, if scalability for overhead, for example, I can say that. So is it high communication is good or not? For what is the improvement? Maybe I'm not sure because we need to go to the paper, okay, journals, why they say this, whether good or not, I'm not sure. Maybe this one is good, maybe it's not because of this overhead, for example. This is, I can say is a parameter. Scalability parameter, for example, limited scalability due to overhead. See, and then more scalable for distributed, or other more scalable also for the coarse grain. This is a different kind of this is scope. Maybe good for others and good, good for others. What you call this area and not for good for them and so on. So you have to explore that. Okay. So this is a general term that we found that. So that's why we give to you to explore that. Use cases suitable for share memory for the fine grain and ideal for distributed memory system. It's good for coarse grain, but fine grain is not something like that. Yeah. So for example, so metric multiplication, I'm not sure, small scale simulation, and also for the coarse grain is good for the large scale simulation and also distributed databases. Yeah, very good for the example. So we can show to the. So this is an issue of the fine grain and also coarse grain parallelism. Yeah. An aspect of definition for regarding concurrency and parallelism. This is another issue. Okay, so everything for definition deal with the multitask appearing to run simultaneously by interleaving their execution. All right, and then aspect of definition on parallelism deal with the multitask actually running simultaneously by dividing work across resources, so they can achieve that. Okay, and then good for them actually. Yeah, and then for aspect of focus in terms of concurrency, task management, for example, handling I/O, user input, and so on. Okay, form an improvement for the parallelism. It's a good for just generating a focus. And for the execution, as before on concurrency, the task may not run at the same time. And parallelism, tasks run at the same time. For example, on multiple core or nodes. Okay, concurrent and parallelism. There's two things that you need to take notes. Okay, what is the concurrent? But this one, the terms, this one, everything is from the paper that you go through, that you explore, you will find. But maybe there is a difference, but according to the doctor. But there is some general concurrence. Most of the will refer what, but there's no right or wrong actually. Okay, when we write a paper, there's no right and wrong. But when we say concurrent, some researcher, at last you will find that many researcher, will choose a word concurrency, for example, instead of to represent their scenario. Okay, this is the style or environment of the researcher. Okay, not say there's a root for, but it's maybe different. Maybe they refer concurrency for their work. Okay, and maybe some cases, some same case but different. I'm not sure, but yeah, that's why when you more on research, you will know that. Yeah. Okay. Concurrency and for the goal, improve responsiveness and efficient in task handling. And then for parallelism, the goal maximize throughput and reduce computation time. Okay, we have to keep on familiar with this kind of terms, everything that they use actually on this parallel concept of HPPC, and use cases, okay, for concurrency, handling asynchronous events, multitasking, input-output bounds, tasks, and for parallel CPU task, large-scale simulation, and data processing. And then finally, for example, in HPPC, managing communication between nodes while computing this one example, performing metric multiplication across multiple processors. This quite often, so many things, quite complicated and complex also. All right, I can say that. Yeah. Okay, this is quite interesting. Yeah, HPPC. So this is part of the key concept on concurrency and parallelism. Looks similar but different. Concurrent and also parallelism. Yeah. All right. Okay, this is a concurrency vs parallelism. So how they illustrate this kind of the concept of concurrent and also parallelism. Pipeline and non-pipeline. So I can say that. Yeah. All right. This is an example. So another challenges in HPPC, we have communication overhead. Yeah. For example, the time and resources spent on exchanging data between parallel processors or nodes in a distributed system include latency, bandwidth limitation, and synchronization costs. And we have quite popular terms in network also, you find this, but load balancing is the word, but referring to different kind of the area. Okay, maybe load balancing in HPPC, talking about distribute work evenly to reduce idle time. Okay, distributed computational work evenly across all processors or nodes to maximize efficiency. Okay, and then another load balancing for ensure no single resource is overburdened while other remain idle. So that's the word for load balancing and HPPC. And also for synchronizations, okay, issue, okay, for example, the coordination of parallel tasks will be also challenges or processes to ensure correct and orderly execution. Yeah, ensure that shared resources are accessed safely and results are consistently, for example. So this is part, I can say this is a term that you, in order to improve synchronizations, so what's the technique used? So what's the previous result? Is it we can improve that? So that's the issue. So if you go for research, that's kind of the thinking that you need to have that instead of just not develop. Okay, for undergraduate, yes, your mindset is just develop. It doesn't care what. When you get the ordering to do that, so we'll do like that. It's like programmers, we don't concern about anything. But if we go for research, you have to concern this and that about it. So we're thinking about, we keep on thinking whether good or not something. Yeah. All right. So data dependency, another also challenges occur when one task rely on the output of another. So this is another topic I can say. Data dependency, if you want to go for the analysis, just that. And also one more thing, that's why I want to make sure everyone choose the unique tasks or unique topics, okay, for them to publish the works later on in that conference. That's why I need to monitor. Yeah. All right. That's a reason why I want you to put the detail of the title, members, and so on. Yeah. So back to here, data dependency. We are managing dependency is a crucial to avoid stalls and accurate correction execution. Okay, so this is another issue for data dependency. Okay, this is more on programming part, debugging and testing parallel program, also programming part. Okay, parallel program are harder to debug due to non-deterministic behavior and race condition. Okay, this is another challenges that are going to improve. Special tools and techniques are required to identify and resolve concurrency issues. Yeah, and algorithm designing algorithm for HPPC require balancing parallelism, load balancing, and minimizing communications and poorly designed algorithm can lead to inefficiencies and scalability limitation, excessively and results are consistent. So this is example of the topic that you can explore. So if you can, but I'm not sure, I not underestimate your capability to do that. So by give a lecture on this introduction part, so I will expose all possibility, okay, for this topic. So this is a huge, I can say huge area. You can explore so many things, okay, by HPPC. Yeah. All right. So finally, summary, the need and importance of HPC. We already discussed that, application of HPC, key concept related to HPC, and challenges of the HPPC. All right, okay, that's all for chapter 1.